Question number 25. Solve 2 times log to the base 3 of x minus log to the base 3 of x plus 6 equals to 1. This is going to be my given function, and what we're going to do here, we're going to find the value of x and then we'll check that whether it is extraneous root or not. Look to this term, 2 times log to the base 3 of x. We know that according to the rule, whatever you have in front of the log, it becomes the exponent of the x. So can I write log to the base 3 of x to the 2? Yes, I can write. Simply write log to the base 3 of x squared minus log to the base 3 of x plus 6 equals to 1. As I said, there is a rule, whatever you have in front of the log, it can be the exponent of the x. So 2 times log to the base 3 of x can be written as log to the base 3 of x squared. Now, I have log to the base 3 here and log to the base 3 here. Now look to this expression. I have log to the base 3 of x squared minus log to the base 3 of x plus 6. Now can I apply the logarithmic rule, which is the logarithmic quotient rule? It is like log a minus log b, which equals to log of a over b. There is negative, therefore it will be log of a over b. We have discussed in the previous example that look, the bases for both the logs should be same. There is log to the base 3 and here is also log to the base 3. But what if I put log to the base 4 here? Can I apply that simple logarithmic rule? No, you cannot apply. For the rule to be applied, log on both of the sides must have same base. Like here, log to the base 3 and log to the base 3. So I can apply the rule. Therefore, it can be written as log to the base 3 of x squared or x plus 6. Just apply that logarithmic quotient rule. According to another basic logarithmic rule, can I write x squared or x plus 6 equals to 3 to the 1? Up to here, we have done the logarithmic quotient rule. Now, at this stage, I'm going to apply the other logarithmic basic rule. This y, which is the 1, will be the exponent of the 3 to the 1, and this x squared or x plus 6 will be here. So this expression can be written as x squared or x plus 6 equals to 3 to the 1. 3 to the 1 is 3. So multiply both of the sides by 3. I will have x squared equals to 3x plus 18. Bring this 3x plus 18 to the left to have x squared minus 3x minus 18. It is a quadratic equation. Let me make the factors out of it. So x plus 3 and x minus 6 are the two factors, which implies that x equals to 6 and x equals to negative 3. These are the two roots which are the values of x. Now to check that whether these are extraneous roots or not, we're going to plug in the values of x equals to 6 and x equals to negative 3 in the given function. If the left side equals to the right side, then it is not extraneous root. But if left side is not equal to the right side, then it will be the extraneous root. Let's check it out one by one. We are doing a simple check here. Plug in the value of x equals to 6. We are trying to plug in the value of the first root, which is x equals to 6. So wherever there is x, plug in x equals to 6. X equals to 6 here and x equals to 6 here. Now look to this part. We know that according to the rule, whatever you have in front of the log, it will be the exponent of the x. For the x, I have 6. So I can write that log to the base 3 of 6 squared. Similarly, 6 plus 6 will be 12. Therefore, I can write that log to the base 3 of 6 squared equals to log to the base 3 of 6 plus 6 equals to 1. 6 plus 6 is 12. So I have log to the base 3 of 6 squared minus log to the base 3 of 12. Again, apply the simple quotient logarithmic rule. It is like log of a minus log of b. It equals to log of a over b. So log of a over b equals to log a minus log b. Just apply that rule, but make sure both of the logs should have the same base as we have it here. There is 3 and here is 3. So I can apply that rule. Now I can write that log to the base 3 of 36 over 12 equals to 1. Divide 36 by 12, I will have log to the base 3 of 3 equals to 1. Now to apply the simple basic logarithmic rule, this 1 will be the exponent of the base 3 to have 3 to the 1 equals to 3. So 3 to the 1 is 3. There I got that left side equals to the right side. So I can say that x equals to 6 is not the extraneous root. 6 to the 2 is 36. 6 plus 6 is 12. So I will have log of a over b. Let's suppose this is my a and this is my b. So I will have log to the base 3 of 36 over 12. Divide 36 by 12. So I have now log to the base 3 of 3 equals to 1. Now according to another basic logarithmic rule, this 1 will be the exponent of the base 3, and this 3 comes to the right side. So I will have 3 to the 1. This 1 is the exponent of this base 3, equals to 3, equals to 3. 3 to the 1 is 3, so 3 equals to 3. So we got that left side equals to the right side. In a case where the left side equals to the right side, the root is not extraneous root. So we just tried that x equals to 6 is not the extraneous root. Let me check x equals to negative 3 now. Plug in the value of x equals to negative 3. This is my second root, which is x equals to negative 3. Plug in that x equals to negative 3 here, and x equals to negative 3. So log to the base 3 of negative 3 is undefined, if you remember. Log of a negative number is undefined and log of a 0 is undefined. This section is undefined. Here I will have log to the base 3 of positive 3. So all I can say that this left side, this is the whole, this whole part is the left side. So this left side is not equal to the 1. What is my right side? My right side is 1. So if it is not equal to the right side, then the root is extraneous root. Now why I stop it here? Because I have a problem here. Log of a negative number is undefined. So I cannot proceed further. I cannot do all this procedure for this because here I got undefined things. So I can't solve this further. So in a short I can say that this left side is not equal to the right side. So there the process has been failed. I can say that x equals to negative 3 is the extraneous root. This is going to be the extraneous root. X equals to 6 is not the extraneous root, but x equals to negative 3 is the extraneous root. When I plugged in x equals to negative 3 in the given function, I got this expression, which is undefined expression. So the left side is not equal to the right side. Therefore, x equals to negative 3. This x equals to negative 3 root is the extraneous root.